Good morning. My name is Tanmay Sri Chauhan Paltia, currently pursuing a degree at IIT Kharagpur in Ocean Engineering and Naval Architecture. Today, we will learn about one of the interesting topics of conic sections, which is parabola. We will be focusing specifically on the equations of parabola in their standard forms. We'll also explore their geometric properties, including foci, eccentricity, as well as parametric equations, and we'll go through the equations of tangents and normals too. In the end, we'll try to solve a problem to better understand the concepts. So the basic definition of the parabola is: a parabola is a set of all points in a plane that are equidistant from a fixed point, which is called focus, and a fixed line, which is called directrix. So let us take a fixed line L as directrix and a point F as focus. So let us draw some perpendicular lines to the curve and let them join to the focus. So let us name the points as P1, P2, P3, and the points on curve as B1, B2, B3. So FB1 will be equal to B1, P1, FB2 will be equal to B2, P2, and FB3 will be equal to B3, P3. So this is the basic definition of the parabola. So the line through which the focus passes and is perpendicular to the directrix is called axis. And the point of intersection of the parabola with the axis is called vertex. So this is called vertex. So if I have to speak about eccentricity of parabola, it is defined as the ratio of distance from focus to distance from directrix. So E is equal to distance from focus by distance from directrix. Therefore, E will be equal to 1. So eccentricity for parabola equal to 1. Now moving on to the standard form of the parabola, the equation will be y square is equal to 4ax. So in this equation, we can clearly see that the value of a will be positive. So the distance from the vertex to focus as well as the distance from the vertex to directrix will be equal to a. And the equation of directrix is x is equal to minus a. And if we take any point on the curve, that will be represented as 80 square comma 280, where t is the real parameter. And the coefficient of x, which is 4a, is known as the length of the lattice vector. So moving on to the leftward pointing parabola, the f will be minus a comma 0, the vertex will be 0 comma 0, and the equation of directrix will be x is equal to a. And if I point on a curve, then it is represented as minus 80 square comma 280, and the equation will be y square is equal to minus 4ax, and the length of lattice rectum will be same, that is equal to minus 4a. So here are the upward and downward parabola. I'm not gonna brief them much. So the equation of upward parabola will be x square is equal to 4ay, and the downward will be y square is equal to x square is equal to minus 4ay. So moving on to the equations of tangent to a parabola. Equation of tangent we study in three different forms. One is point form, other one is parametric form, and the other one is slope form. So when we talk about the point form, the technique is that if x1 and y1 happens to be a point of tangency for parabola y square is equal to 4ax, then we can write the equation of tangent in point form as t is equal to 0. T is equal to 0. How do we get t? The question is, how do we get t? From the equation of curve, we can obtain t by substituting x square with x1, y square with y1, and x with x plus x1 by 2 and y with y1 by y plus y1 by 2. So in this equation y square is equal to 4ax, we have two variables, which is y square and x. So if we substitute y square with y1 and x with x plus x1 by 2, then we'll finally get the equation as y1 is equal to 2a times of x plus x1. So this will be the equation of tangent in point form. So in parametric form, there is already the points are given as 80 square comma 280. There is nothing to do, just we have to substitute the values of x1 and y1 as 80 square and 280. x1 as 80 square and y1 as 280. Then we'll end up getting this equation, that is ty is equal to x plus 80 square. This will be the equation of tangent in parametric form. Now slope form, the condition of tangency for slope form y square is equal to 4ax will be a by m. This means when the line of a slope m written as y is equal to mx plus c, where c is the y-intercept, this happens to be a tangent to y square is equal to 4ax if and only if the y-intercept c is a by m. So therefore y is equal to mx plus a by m. So this will be the equations of tangent. And moving on to the equations of normal. Again, equations of normal can be done in three different forms. One is point form, parametric form, and the slope form. So the point of tangency at which we have drawn the normal, then we have to first write the equation of tangent in point form. From these we will get the slope of the tangent, and negative reciprocal will give us the slope of the normal. And now we have already have the points as x1 comma y1, then we have to substitute them in that equation. Then we'll get the equation as y minus y1 is equal to minus y1 by 2a into x minus x1. This will be the point form of a normal. And parametric form, write the equation of tangent in parametric form. Replace x1 with 80 square, which is given, and y1 with 280 square. Then we'll get the equation as y is equal to minus tx plus 280 plus 80 cube. And then finally a slope form. So y is equal to mx plus c happens to be a normal curve to y square is equal to 4ac, provided c is equal to minus 2am minus am cube. So if c is equal to minus 2am minus 2a cube, then it will be the slope form of a normal. And now let us solve a problem. So let us read the question. If h comma k be the point on the parabola x is equal to 4y square, which is nearest to the point q 0 comma 33, then the distance of p from the directrix of parabola y square is equal to 4 into x plus y is equal to. So first let's draw the diagram. This will be the parabola, and this is the point 0 comma 33, and somewhere here we'll point p as h comma k. So this will be the shortest distance. So from the equation x is equal to 4y square, we get a is equal to 1 by a is equal to 1 by 16. So equation of normal for x is equal to 4y square passing through 0 comma 33 will be, so the equation is tx plus y is equal to 2at plus t cube, at cube. So on substituting x is equal to 0 and y is equal to 33, we get y is equal to 2at plus at cube. Then 33 is equal to 2 into 1 by 16 into t plus 1 by 16 into t cube. So the equation will be t cube plus 2t minus 16 into 33 is equal to 0. So t cube plus 2t is 18 minus 2, 528 is equal to 0, which will be equal to t square into t minus 8 plus 80 into t minus 8 plus 66 into t minus 8 will be 0. Then t minus 8 into t square plus 80 plus 66 will be 0. This will be d will be greater than 0. So no real roots. Therefore t will be equal to 8. Now h comma k will be equal to t square by 16 comma t by 8, which will be equal to 4 comma 1. Now let us understand by diagram. This is a parabola. Somewhere we have the point as 4 comma 1, and this is the x is equal to minus 2. So y square is equal to 4 into x plus y. This will be the second parabola. So y square minus 4y is equal to 4x. Adding 4 on both sides, we get y minus 2 whole square is equal to 4 into x plus 1. So directrix will be equal to x plus 1 is equal to minus 1 and x is equal to minus 2. So this will be the directrix, which is the point is minus 2 comma 1. They have asked the distance of this. So 4 plus 2, which will be 6. So the answer will be 6. Thank you.